Dicarbon is a green chemical made up of two carbons. It's still largely a mystery to chemists because it normally exists as a gas detectable at extremely high temperatures in certain conditions like on comets or blue flame. In a world first, Taiwan researchers have found a way to stabilize dicarbon by binding it to a single molecule called a ligand. The stabilized dicarbon can exist as condensed matter at room temperature, allowing it to be used in a lab. The discovery opens up possibilities for new exploratory studies on the nature of this elusive chemical.
The Academia Sinica has found a way to stabilize C2 molecules at an ambient temperature. Dicarbon is typically known as a gas. Due to its high reactivity, it's been difficult to isolate as a solid or a liquid.
Pretty much, if you use a very normal term, is basically we use sort of like you think about C2 is a very negative, very reactive. So we actually design a clothing that we put in the C2 so that they are more stable. And when they are stable, we can actually investigate and to examine the chemical reactivity or their structure property of the C2. Yeah.
Academia Sinica researchers found a straightforward way to stabilize the elusive chemical. In a world first, they found they could stabilize it by binding it to a single custom-made ligand. Developed over 2 years, this ligand is made of two imidazolidine 2-iminoto groups.
We can claim that our lab are the first lab that use one ligand or monoligand to stabilize the dicarbon, very reactive dicarbon, at the normal temperature. And previously, some labs attempt to stabilize this dicarbon, but they use two ligand or more ligand to stabilize that. Once if you put more ligand or two or more ligand on the dicarbon, pretty much the property of the dicarbon disappear.
Researchers say the discovery could lead to unprecedented research projects on dicarbon. In the future, it could even support the development of new materials for semiconductor application.
Because some of the people, they use a carbon-based material to use for semiconductor, and also the carbon is the same group of metal, same group of element as a silicon. So it may provide some sort of new material for the semiconductor application, but it still is far too long to the real application.
Researchers hope that their stable C2 molecule will open up new doors for future applications and provide methods for researchers to stabilize other reactive materials. The research was recently published in the international journal Nature Chemistry. Formosa News, Stephany Yang, Lu Botong in Taipei.